Shashank, can you check once our live to Sasan? Voice can I send it? Sir, এবাৰ আপুনি কিবা এটা ক'ব।
Okay. শুনিছা?
Okay, sir.
Hello.
হয়, sir.
Okay.
Sir, হ'ব, sir.
Okay, thanks.
Okay, কাম কৰি আছে ইউটিউব কাম কৰি আছে।
Okay, sir. So we can go live, sir. So welcome everyone. First of all, I'd like to welcome you on our first event of 2021. So we have among us Dr. Shishir Kalita. Shishir Kalita is a postgraduate from IIT Guwahati. He is a data scientist in Armsoftech.air. So we would like to welcome him on behalf of Assam Engineering College Developer Student Club. So sir, the time is all yours. Sir, go ahead, sir. Thank you, sir.
Okay. Thank you, Subrat. Subrat and entire team, Developer Student Club, Assam Engineering College. Good evening and Happy New Year to all of you. Okay, so first of all, my talk will be on it will be a very basic talk, like how to build a ML project, machine learning project, and maybe how to build machine learning models, and what are the things you should care of, and all those things I'll talk about. Okay, so as Subrat mentioned, I am working as a data scientist in Armsoftech.air, and I've working on for the speech technology, like speech recognition, then language identification, then speaker recognition, and some kind of speech analytics for to analyze the customer agent and customer conversation. So those are the areas I am currently working on. And in between the talk, maybe if you have any question, then feel free to just stop me and ask the question. Okay, in that way, actually, it will be more interactive. Okay, so first thing is that, like, what are the key steps for a ML project? Then going to that, like the core part is the machine learning model and how we can train one machine learning model. Okay, so once we train the machine learning model, we'll get the accuracy or maybe some kind of valuation metric we have, and on what basis we'll improve our model. Okay, so in that way we'll come across the bias variance problem. Then how to solve this kind of bias variance problem we will just talk about, and different kind of regularization what will include in case of models, and then the different other regularization methods are there. Then when you build a machine learning model or as a whole machine learning project, at that time you have to take care of the evaluation metric. That is more important thing. Okay, so what are the evaluation metric we have for different projects? Maybe for speaker verification it will be different. For machine translation, like one language to another language translation, the evaluation metric will be different. You have to clearly define your metric. Okay, so that also we'll discuss, and at last I'll talk about one case study, because these case studies are very important. Like, you should have one proper problem formulation if you want to work on a machine learning project. Then how to formulate, actually those things I'll discuss, and how to step by step you can do a project. Okay, so I'll not go very depth into maths, so just overall this will be a overall talk, actually. Okay, so here actually these are different kind of ML projects. There are different lots of different maybe ML projects will be there, but these are a few, actually. So first thing is the voice bot. If you talk about the voice bot, the first thing is that it should convert the speech to text. Okay, so then from that text you have to get some kind of understanding what that person is intending to talk about. That is the message, what message that person is want to deliver. Then after that, once you get that understanding from that text, after that you have to generate one answer. Okay, then that answer will be in the text only, and you have to replay back that answer using the text to speech conversion. So this is come to the TTS. Then another thing is that speaker verification. Then some kind of speech analytics you can do, like if you get some customer and agent conversation for some kind of some financial problem, or maybe due to other problem, at that time you can have some you can just take those speech and you can get some understanding from those to both the conversation. Then coming to the chatbot, so this chatbot are voice bot will be speech, like there will be some speech signal. For chatbot, you can say like maybe text will be there. You can write and you can ask the query. Then there may be some kind of health diagnosis bot where you can interact with that bot. If you have some issues, then you can just interact with that bot and you can get the suggestion from that bot. Then this self-driving car nowadays is very popular. Then there may be some other kind of thing like AI powered visual inspection platform for quality control. Maybe you can have one camera and which analyze whether some kind of crack is there in, or not in the IC, or maybe in some other material. So those kind of things may be there. Apart from that, there are lots of different ML projects will be there. You can just check those things in online. So now, what is the key steps while building a ML project? So first step is the data collection. So in case of data collection, if you are doing some kind of project where already data exists, like somebody gave you the data, which is clean, that means everything is there. Like if you are doing some kind of classification problem, that means you have the features, then corresponding labels you have, then you need to worry actually. But you have, if you want to build a ML project from scratch, that means you need to collect the whole data and then you have to process that data. After that, your model training and testing will be there. Okay. Then, in case of model training and testing, what you need to do, you need to iterate your model, and you need to train the model, and you need to test, and you need to check what is the your accuracy, or what is your performance for the test set. Then you have to iterate your model till you get the good result. Okay, so in that iteration, what you can do, you can get some more level data and you pump to the model and you reiterate the model training. After that, once you get that model, so what you can do, you can just deploy the model. So once your model will be in online, at that time also you will get more amount of data. So what generally people suggest, you can, at the first level, you can just deploy a very simple model, maybe if you don't have very large amount of data at the initial point. Okay, so after that, once the user will interact with your model, you will get more number of data day by day. So then what you can do, you can just train the model maybe after 1 month or 2 months. That way you can iterate your model training, and you can upgrade your model. So this is the basic steps how you just people follow for the ML project development. Now, what is the data actually? Like as I mentioned here, the data collection and data pre-processing. So in real world, there may be two types of data. First thing is that structured data. So structured data means tabular data. Like you may get the data in a Excel sheet, or maybe in a CSV file, or maybe in a JSON format. CSV file you just consider. So in that case, what happened? Maybe your each row correspond to each example in that case, or and each column may represent some kind of features. For example, like here you can say this is the house, some kind of database snapshot it is, and here first column is the house size, then second column pin code, then what is the number of bedrooms, then number of price. So in this case, if you want to predict using this house size, then pin code and bedrooms, what is the price for that particular location. So in that way you can do from this kind of CSV data. So this is called a structured data. Now, but in real life most of the data are unstructured. Like unstructured data are image, speech, text and video. So it is very difficult to process this data and get some intuition from those unstructured data. Okay. Now, when you consider the data, data is very messy. Like if you need to build your model from scratch, like you need to develop you need to collect the data first and then do the model development. At that time, it is quite difficult actually. And people say that most of the like machine learning engineer or data scientist, they spend around 70 to 80% of time while collecting the data and maybe pre-processing the data. After that, that model development is there. So while collecting the data, there may be lots of issues, like how you will collect the data. For example, you may scrape from the internet, or you may go to the field to record the audio, or maybe you need to click the snapshot of those some kind of images. Those kind of things may be there. So while scraping those data, if you consider some kind of tabular data or maybe images, there may be different kinds of issues. For example, if you consider this tabular data, there may be some kind of name may be there, or sometimes some value may be not present or maybe zero. So those kind of issues may be there. So and in some of the cases what happen, you may have mislevel data also, like you don't have proper label for those particular examples. So those kind of issues will be there. And in case of speech, there may be like if you want to develop one ASR system, at that time what you will need, you'll need one speech signal, and for that particular speech signal, what is the corresponding text string. But sometimes what may happen, you may not get that texting there. So those kind of issue will be there, and the audio may be too much noisy, and you can't use in your model training. So those kind of issue will be there. Then in that scenario, what you can do, you need to do the data pre-processing. Okay, there are different kind of data pre-processing are there. So these are dependent on what kind of data you have. It is a structured data or it is a unstructured data. So now generally if you consider some kind of structured data, what you can do, like you can do some kind of ignore the missing value. If you have some kind of values are not there, maybe you can just ignore that particular example, and maybe you can fill that value. What you can do, you can just take the average of those some adjacent values, and then you can put the mean of that in whatever the missing values are there. So you can do that way, and you can do some kind of outlier detection algorithm to avoid some kind of outliers from your data. So those kind of pre-processing methods are there. Those you can follow. Then coming to the just assume that you have a good amount of data. Maybe for your task you have some amount of data, and now how you should prepare your data for training the model. So for example, you have a classification problem. Okay, maybe whether a email is spam or fine. So at that time, what you can do is that you have some kind of data, and you have for each example, that means each training example or testing example, you have some kind of level. Okay, whether it is 0 or 1, for example. Now, how you will separate your data? Because once you train the model, you need to have some data where you can validate your result or you can test your result. So in that scenario, what generally we do is that we separate that whole branch of data into 3 categories. One is the train set, second one is the we call development set or dev set, or validation set or fail set, or and another third category is the test set or eval set. Okay, now we'll just check how you can divide the data into your into different subcategory. Now, before actually when before the deep learning era, when we use this SVM or other kind of SVM or maybe GMM or other kind of machine learning algorithms. So at that time, we used to have very less amount of data. Maybe if you go back to maybe 15 years or 10 years, maybe 2010 or 2009, at that time, so you used to have very less amount of data actually. So at that time, maybe for one particular example, you have only 10,000 examples. So at that time, what you should do is that if you have less amount of data, then maybe you can take 80% of data for train set and 10% of the data depth set and another 10% of the data test set. Now coming to the what is the we get that train set is used for the training the model. Now what is the use for development and validation set? So development set or validation and test set. What is the use? Now, generally, this development set is used to tune the model. Like what we do generally, we train the model on the 80% of the data and we test the model on the depth set. Now, if we get some bad accuracy, maybe we can just fine tune the model, for tune the model, and then again we test the model, test the depth set. So whatever the parameter tuning things are there, we do in the generally in the development set. And at last, when we get a good accuracy in the depth set, we test that model. We use that model for testing purpose, testing on the test set. That is the use actually. Now, in present day scenario, you have huge amount of data due to this big data evolution. You will have, in case of image or speech or any text kind of thing, you will get large amount of data. So in that scenario, what you can do, like you have, for example, 10 lakhs images or examples, for example. In that scenario, what you can do, you no need to take 80% of the data for train. You can take 98% of the data for train set, or maybe 1% maybe 10,000. So 10,000 data is fine for the depth set or the test set at that scenario. So you will get more number of files for the training the model. So that way you can divide the train set, depth set or test set. Now, uh, what the data distribution should be for train set, depth set, and test set. So in that case, your train set should be a very diverse set. Diverse in the sense, for example, you want to build a speech recognition. That means converting the speech signal to a corresponding text string. So at that time, here you should collect the audio. That means the speech signal from diverse speaker, one criteria, and another is the diverse environment scenario. Maybe you're from the outdoor scenario, or maybe from the road, or maybe from the other kind of, maybe from different cities, or maybe from the office scenario, or maybe indoors, different kind of indoor scenario. You should record the data. So in that way, your model will be robust enough for testing in the different scenarios. And now, how your distribution for the set distribution for the dev and test set. So for dev set and test set, distribution should be same. Why? Because as I mentioned earlier, that for what we do, we train the model on the train set, and we tune our model in the depth set. Now your depth set distribution and test set distribution should be same. That in that scenario, what will happen if your model accuracy or model performance is good in case of depth set, then only you can expect that your test set accuracy will be also good. Okay, so now generally what happen in real world scenario, you may not have the test set. For example, you want to build one app which can recognize maybe some kind of disease in a plant. Okay, So at that time you just scraped your data from internet, and you for maybe for a particular disease you want to classify. Okay, so, and you get the data from the internet. So once you get the data from internet, or you have some data which is recorded through a very good quality camera. Okay, now once you develop that model, it is a binary classification problem whether disease is there or not. Okay, now for example, you have a very good amount of data, your data is very clean. Okay, but you want to develop you want to deploy that model in your mobile application. Now when user will use that application, they may not take, their mobile quality may be very poor, their mobile camera may be very poor, so your testing environment will be very diverse. Maybe their camera may be very high quality, or maybe very poor quality. So at that time what may happen, so you can expect that your testing scenario is very diverse. Okay, so what you can do, you can just take some kind of depth set data, some kind of files, some kind of images, by considering those testing scenario, and you can test your model on those kind of set. So that set you can consider as a development set. Okay, now what you can do, sometimes what may happen, your depth set may have some kind of mislevels, or maybe your test set may have some kind of mislevel data. Your train set may have some kind of mislevel data. That is okay, because train set is a very huge data set. You maybe you may not get time to check each and every files to correct the levels. But what you can do, you can check those depth set, at least the depth set and test set should be very clean, so that whatever the performance evaluation you are doing, those performance evaluation should be correct. Okay, so that thing always everybody should remember, that your dev set and test set examples are very clean, and your no mislevel, nothing is there. So there are different kind of error analysis are there, which we can do actually on the dev set and test set. For that, maybe I can just I can speak that. So okay, now what is the steps, like once you get that data, you have the data, training set data, then what is the steps to train a model? So what we do generally, like we have one particular data set for image classification maybe, or text sentiment classification, or maybe different kind of scenario. So at that time what we need to do, we need to define your model, what model we are going to use at that. And what is the structure? Structure means if you want to use a neural network, what may be the hidden layer size, for each hidden layer how many neurons will be there, and how many hidden layers will be there, what kind of regularization or what kind of activation you will use. So those kind of things you need to decide first. After that, what you need to do, you need to normalize your input. That I'll talk about, what is the normalization of the input. Then there will be parameters in every nodes. There will be some parameter like weights or bias. Those kind of parameters will be there of the model. So those parameters you have to initialize. So there are different kind of initialization techniques are there, so that you need to use. After that, what we will do, we need to learn those parameters for that particular model by minimizing some kind of cost. Okay, so in that scenario what we'll do generally, we'll take one example and we'll do the forward propagation. Forward propagation means we'll just compute the for that particular training example, we'll calculate what may be the prediction. Okay, and then what we do, we'll just check what is the true level, and we'll do the some kind of cost function from that predicted value, and whatever the real level value, and do some kind of back propagation to update the gradient. So that way we will learn the model. Okay, after that, once you learn those parameters, you can use those model parameters and for that particular model to test on the test set. So this is the general structure how we train a model. Okay, one second, huh? Subrat, is it fine? Like, okay. Oh, okay, fine. Yeah. So now what we can do, and another thing, Subrat, like till what time I should like speak? Maybe 8 or okay, fine. So now let us consider a very simple model. So very simple model we can consider as a logistic regression model. So logistic regression, this is a binary classification model. You can do binary classification using that model. Actually, you can extend the multi-class classification also using that logistic regression model. But just for a very simplified case, you can just take we want to solve one binary classification problem. So binary classification means whether that one particular plant has disease or not, for example, yes or no. Okay. So now what we need to do, we need to define our training set. Okay. So these are some mathematical representation. Like we have n numbers of examples. Okay. And for each this x this superscript 1, that means this is a one particular example. Okay, and for that particular example we have one label y1, and in that way in whole training set we have m numbers of examples. Okay, so now what we do, what logistic regression model is, this whole equation whatever you have seen, this y hat equal to this y, this is the sigmoid function. So in that way we can train using this model, we can just train one simple logistic regression model. Okay, so maybe you can just consider this this one in the figure right one. This is a very basic logistic regression model where these three inputs are there. So that means for this x, whatever the x superscript 1 is there, this is one example, and for each example we have three features. Okay, x1, x2, and x3. Okay, now let us consider this x1 will just input to this sigmoid function. Okay, this logistic regression model. Okay, so since we have three inputs, we have three weights. Okay, w1 for the x1, w2, and w3. Okay, so this w transpose x, this is the inner product. So what we do, we just multiply with this w1, w2, w2, then x1, x2, x3, then you will get one particular value. So if you feed this value here, you will get y hat one particular value. Now for this example x1, you will have this label y1, and your prediction is y hat. Maybe you can consider it as y hat superscript 1. Okay. So what you need to do, you need to take the difference. What is the difference of y1 and this predicted version of the y1? Okay, and that is called the loss, your loss. Like what is the prediction and what is the true level, and what is the difference, that is the loss in the simple sense. And we need to propagate that loss from the output to the, that means from this side, this right side to the left side, then this is called a back propagation. Okay, so that way we will learn the weights. So now what we need to do, as I mentioned here, there's this, for a particular example you will have the prediction y hat and one true level y I. Since here we considered m numbers of examples, we need to sum over all the examples. Then this loss L for y hat I and y hat 1. Okay, we need to define what this L is. Okay, so generally different kind of loss are there. So here we consider is that binary cost entropy loss. Okay, maybe if interested person can just look into what is the detailed explanation of this binary cross entropy. I'll not go to that deep depth on that, and you just to consider one thing is that this binary cross entropy, this loss actually it is a convex optimization problem. So that means you have a global minima. Okay, so if you considered here two parameters w w and b, just for example here you have three parameters. I'm just talking about this w1, w2, w3. Just for a simple case, you just considered we have only two parameters, only w and b, for example. Okay, and then you can just plot that this loss in a three-dimensional diagram. Okay, so what your criteria? Now, what you need to do is that you need to minimize this loss and minimize that loss for that particular w and b, which minimize this loss. Okay, so now what we need is that we need one optimization algorithm which will do for us. Okay, that optimization algorithm we need to apply on this, and we need to find those w and b which minimize this value, this j, w and b. Okay, now if you plot this j, w and b with respect to this only two parameters, you will get this kind of convex function. Okay, this is called a convex function, and you need to find, you need to look, you need to go to this value, this this local this global minima, I can just say global minima, and we need to check what is the value for w and p. Now thing is that how we will reach that particular point. Okay, so for that you will be needed one optimization algorithm. Okay, so now there are different kind of optimization algorithm. The basic version maybe you can just check is a gradient descent algorithm. So what is a gradient descent algorithm? Now let us simplify again your loss function. Earlier in this loss function you have two parameters w and b, that's why it is a three-dimensional plot. Let us consider only one parameter. That means in this particular diagram you have x1 and w1 and then sigmoid function and then prediction. Just consider that. So in that scenario, if you plot that plot the loss with respect to that particular weight, okay, you will get this kind of convex function. Okay, so now what you need to do, you need to just initialize, because whatever the weights you will have, maybe initially you need to decide a particular weight. In the steps for the training the machine learning model, as I mentioned, we need to initialize the parameter. So now in this simple logistic regression case, you have the what is your parameter, only w. Okay, only one weight. Okay, and you need to initialize that weight. Okay, so for example, you initialize the weight here. There you need to write, for example, random np dot random kind of thing, then you will get one value and you just get your initial weight is here. Okay, but what is your global, this clause global minima is here. Okay, so you need to reach from this point to this point. How you will go there? Using the gradient descent algorithm. Okay, so what this is your initial weight. Okay, and at this point you need to find the gradient. Okay, so then at this point you need to find the gradient. This will be in this left direction. Okay, so then you just take the minus and then you will go to this direction. Okay, if your weight is here, then you have to add this gradient in your initial gradient and you will reach here. So iteratively you have to do and at some point you will reach here. Okay, so that way you can go. So here actually you can, if you check here, okay, see that here maybe you can initialize the weight and it will reach here. Actually that animation is not playing now, but in this case actually we have initialized here and slowly it will converge to this point. So this is a minima point, so it will converge to here using this gradient descent algorithm. Okay, so now there are different kind of actually the algorithm, different kind of optimization algorithms are there, but this gradient descent is generally people widely use, and there are different advanced optimization algorithms are there. Maybe gradient descent with some kind of momentum, you can give some kind of add some kind of momentum value, and Adam and RMS prop, those kind of algorithms are there. You can check actually if you, when you build a model, you can very like check with different kind of optimization algorithm. Wherever you get the best result, you can just consider that one. Okay, now while writing the code, for example, if you want to write one machine learning model from scratch, for example, logistic regression model. Okay, so at that time you have to decide the how you will do the training. You will have some kind of epoch, those kind of concepts are there. Okay, now what is the for gradient descent, actually different variants are there, based on the how many files, how many images or how many examples you will consider to update your parameter. Okay, so in that way you will have stochastic gradient descent, mini batch gradient descent, and batch gradient descent. Okay, so now this actually these things you should know very clearly. Okay, so now for example, you have your training set has m numbers of examples. Okay, so now in case of stochastic gradient descent, what will happen? You need to calculate error for each example. Okay, and update the model for each example. Okay, so you need to calculate the error for one example, and then you need to update the model parameter for that particular example. Okay, now if you have mini batch gradient descent, what you can do, you can take a batch, that means which is less than this m, which is less than all whole numbers of example. Like for example, you have 100 number of examples for in the chain set. What you can do, you can just consider 10 numbers of examples at a time, which is called a mini batch, and you can compute the error for that particular batch and update the model parameter for that particular batch. So now for if you have 100 number of examples, if you have 10 examples mini batch, then how many mini batch will be there? You have 10 mini batch. Okay, 10 cross 10 cross 10 100, then 10 mini batch will be there. Okay, so that means you need to update your model parameter 10 times, like that. But in this case, stochastic gradient descent, what will happen if you have m numbers of, that means if you have m numbers of examples, and for each examples you need to update your parameters. So for that particular m numbers of if you have 100 numbers of examples, you need to update your parameters for 100 times. Okay, for that to see whole 100 numbers of examples. And batch gradient descent, what will happen, you need to take whole 100 numbers of examples and you do the update. So in case of batch gradient descent, what will happen, for a particular 100 numbers of examples, you need to update one time. Okay, so that means for stochastic gradient descent, you need to update 100 times for a particular 100 size of data, 100 size examples. For mini batch size, you need to have 10 times because your mini batch size is 10. For batch gradient descent, you need to have one time to upgrade the model parameter. So now once you train the model, actually at that time you have one parameter which is called epoch. This epoch is actually hyperparameter. Okay, you need to decide how many times you want to train your model. Okay, so now what is a epoch actually? So epoch is one cycle through the entire training set is called the training epoch. Okay, so that means one epoch means that that model will see whole bunch of training set of data. Like if you have 100 examples, that model will see all the 100 examples to update the parameter. Okay, so that means in case of batch gradient descent, what will be a number, how many numbers of iteration per epoch? It will be one. Okay, let us check one example. If you have number of examples is 1000, if your batch size is 10, okay, for stochastic gradient descent there will be 1000 iterations per epoch, because you need to do one examples to update your parameter, and that way you need to do 1000 iteration to see whole amount of data. Okay, for mean weights gradient descent there will be 1000 by 10, so there will be 100 iterations per epoch. But for batch gradient descent there will be one iteration per epoch, because you will use whole bunch of data to update your parameter. Okay, so that you should know while writing your own program. Okay, so maybe I can just show you. Okay. Okay, here I can show you, like this is a very maybe simple PyTorch version of the code, where you can just check actually when you run your code, you can get like for epoch in range, if you have 100 epochs, then you need to run those model for 100 times. Then you just take the train loader. Here, this is a loader, actually data loader, where your batch size, depending on the batch size, your train set data is separated. Okay, so for each batch you need to, what you need to do, you need to take this forward pass first. Okay, forward pass means you need to take the model and pass your data, and you will get the y hat, that means prediction. Then compute the loss. Okay, so loss means your this y batch, your this true level, and this is your y hat, that means for that particular batch what is the prediction. Then you need to do the backward pass. So backward pass, then in that backward pass the gradient will be computed, and you need to update your parameters. Optimization step, you need to update the parameter, and you can check actually loss. You need to take the loss and just append in, and you, at the last you can check what is the, how the loss is propagated. You can check, and in that way you can just test your model also here. Okay. Then earlier I was talking about the normalization of the input. Now, what is the requirement? For example, if you have one train set, and your, for each example you have two parameters or three parameters, for three features, for example, and one features maybe range from 0 to 1. Okay, and another features maybe range from 1000 to 10,000, for example. Like in case of house prediction algorithm, if you check here. Okay, in case of house prediction, this one. Okay, this one, maybe your house size will range from maybe 800 to maybe 1700 or kind of thing square feet, or your bedroom number of bedroom will be maybe range from 1, 2 or 4, like that will be there. Okay, so sorry, huh? Okay, so in that case what you can see is that your this what you can see is that your range of those features will be very different. Okay, so what you need to do, you need to normalize your feature value so that it will end up in the same range. That is called the feature normalization. Okay, so for feature normalization, what you can do, you can just take the train set and then take the mean value for each features, take the take the subtract the mean value and divide it by the standard deviation. So that way you can normalize your train set. Okay, now coming to the test set. While how you will normalize your test set, because when you do the testing in maybe in real life, when you take the snapshot of your image and you need to predict the disease, whether disease is there or not. So how you will do? So what you can do is that you can store the train set mean and train set standard deviation for each value of the features, each features stored somewhere, and when some test example will come, and you need to just take the, you need to subtract the mean of the train set and divide it by the standard deviation. So that is a standard way of doing that normalization for the test set. Now, why we should do the normalization? There are different explanations are there. If you just check the Andrian video, it will be more clear. Just simply, I can just say is that if your values are very different, like one is maybe 0 to 1 and other some values, some features values maybe 1000 to 10,000, then what will happen, your this cost function will be squeezed actually, maybe squeezed like this. Okay, so at that time when you train your model, at that time it will take very lots of amount of time to train your model. Okay, but if you normalized, what will happen, your cost function will be very circular kind of thing. Okay, and then you, that can be your loss, your gradient descent algorithm will not take much of time to train your algorithm. Okay, so that is the basic thing actually why we should normalize the input. Yes. Okay, so then another thing is that how we should initialize our weight. Okay, so there are different kind of initialization methods are there. One kind of is that these are not good actually. Zero initialization, you can just take the zero and each layer, and then these are not suggested. Then you can do some kind of random initialization. What you can do, you can in maybe in Python you can just np.random.random, then this is the number of layers in a particular time, and then number of layers in the maybe number of layers in the first layer and the second layer in the first layer, like that. You can just take one matrix and you can just initialize the weights using the this kind of random initialization. But sometimes what happen, if you initialize through this random initialization, it may not be good actually. Sometimes it will be quite difficult to get the local minima, the global minima. So there are different kind of initialization techniques are there. One is called he initialization. So at that in this kind of initialization, it will take considered is the number of it will consider the number of neurons in the previous layer and do some kind of this squaring thing. So this way actually people suggest that we should use this kind of initialization. There are different other kinds of initialization techniques are also there, you should take care of. So this is one important thing when we do the model training. So everything is built-in functions are there when you use PyTorch or Keras or TensorFlow. Everything is there. You just need to define that initialization technique. Now coming to the bias variance problem, like what is the bias and variance problem? This is actually an important task. Okay, so now what is the bias variance problem? So what we need to do is that we just train one model, okay, and test on the same training set. Okay, you train the model and do the testing on the same train set, and after that you test on the test set. Okay, now if you check the accuracy, if you not accuracy, maybe you can, in case you can check the error rate, then if you found that your train set error rate is 25%, this is not good actually. That error rate may be very less, maybe 1% or 2% like that, and your test set error is also very high. Okay, so in that scenario, what you can say is that your model is not properly trained. Okay, so this is called the overfitting problem. This is called the underfitting problem. Your model is not trained properly. Okay, and sometimes another situation may arise is that your train set error is very less actually, 1% or maybe 2%. But when you test your model on the test set, you found that your test set error is the 12%. That means accuracy is the maybe 89%. Okay, so in that scenario, what will happen? Your model overfit in your train set. This is also not suggested, also not desirable. Okay, so now what is the good model? Maybe so a good model, maybe your train set error rate is 1%. That means accuracy is 99%, and test set accuracy maybe your 98%. Okay, now while when I talk about this 1%, 2% kind of things, at that time I need to check like what is the human level performance. Okay, because if your human level performance is 100%, okay, at that time you can achieve the 99% train set accuracy maybe. Okay, but if your human level performance is 80%, okay, so at that time what you can say is that 75% using your model is good enough actually. Okay, so that is the important actually while doing the this kind of evaluation, analyzing the evaluation metric. Okay, so what is your human level performance that we need to consider. Okay, so human level performance means, for example, while doing actually in my PhD, while I did some kind of analysis for a pathological speech. Okay, so I need to analyze the what intelligibility level for a particular pathological group. Okay, so now that speech language pathologists, they listen the all the speech examples of a particular children, and then they judge whether they will give some rating, maybe 0 to 10. They will give some rating. If 10 if very highly intelligible, 0 means very less intelligible. Okay, so in that scenario, what will happen, these are some kind of bias may be there, like each speech language pathologist will have some kind of bias, and in that scenario you can't achieve 100% accuracy on the human level performance. Okay, maybe 80% human level performance is good actually. So in that scenario, if your algorithm will give 70% or 70% accuracy also, it is fine at that time. But if your human level performance is 98% and you are getting using the model you are getting 70%, this is not good. Okay, that we should we need to check. Okay, and if it is a high bias, actually your model is not properly trained actually, that's why it is not able to separate. And if it is a high variance, your model actually modeling the noises also, like very noises also, but when you test your model on the test set, your accuracies will be very bad. Now, how to overcome those things? Now, if you have high variance problem, that means what happened? Your train set accuracy is very good, but test set accuracy is very bad. Okay, so at that time, what you can do? You can just pump some more training data. Okay, this is one criteria. And another thing is that what happened when your train set accuracy is very high and test set accuracy is very less. At that time, what will happen? We can think of that your that model actually very complex. We can just in simple sense we can check is that tell us that is very complex. So what we need to do, we can just simplify the model. So to simplify the model, what we can do, we can do some kind of regularization method. Okay, there are different kind of regularization where you can just do some weighting penalty, some kind of thing, that L2 regularization and dropout, those kind of regularization we can do. Okay, so while doing L2 regularization, what you need to do, you need to add some kind of regularization parameter along with your cost function, and you need to check which parameter you want to regularize. Okay, and generally we do regularization of the weight value. Okay, then dropout, I'll just talk what is dropout actually, because these are very useful nowadays while training these deep models. Then another thing is that early stopping. You can check the you can give some validation set along with the train set, and you can check whether this loss is gradually decreasing or not. Okay, and if some point that loss is become increasing or the training set accuracy is decreasing, at that time what you can do, you can just stop your model. Okay, so this is called the early stopping, in simple sense. Or another simple method is that you can just decrease your model size. Like if you have 10 hidden layers, maybe you can reduce maybe 7 or like that. This depends on the experiment method only, hidden try and error method. So you can do that way also. Now, if you have high bias, that means your train set accuracy is also very bad. Okay, so at that time your model is not properly trained actually. So what you can do, you can just increase your model, maybe number of neurons or number of layers you can increase, or maybe you can train your model a bit long time. Okay, and you can try with different kind of advanced optimization algorithm apart from as stochastic gradient descent. So those kind of things you can try to avoid the high bias problem. Okay, L2, as I mentioned, L2 regularization, you need to add one parameter here. Here actually we want to regularize this weight. This is the lambda parameters. You need to decide this, you need to give this lambda parameters as a hyperparameter. So that we can do actually. Then dropout, actually it is very simple one. What we do, when we do the training, you need to feed this is a standard neural network. Okay, all fully connected, all connections are there. Okay, so you need to give one example and you will get the output. Okay, maybe a mini batch or maybe a batch gradient like that. Okay, so what we can do is that you can just randomly cut some of the neurons. Okay, maybe for first batch you just cut these two neurons in this in this layer, and cut this one layer, this one neuron and this one neuron in this layer, and maybe these two neurons in this first hidden layer. Okay, so that way you can just randomly cut the neuron. Okay, and you train the model. Okay, that way what will happen essentially, actually this model becomes simple compared to this model. Okay, so this is called a dropout regularization. So you need to give for particular layer what will be your probability of discarding the neuron. Okay, how many neurons you want to discard for a particular layer, so that you need to give as a hyperparameter. So in Keras, actually these things are there. You can just give that parameter, or in PyTorch. Here actually different kind of other regularization parameters are there, methods are there. One, if you have very less amount of data, for example, if you want to do some kind of emotion classification in speech, maybe you will not get much amount of data. So what you can do some kind of some kind of data augmentation. Maybe you can you can add noise, maybe some white Gaussian noise, then babble noise, maybe some kind of music you can add. Those kind of things you can do, and you can increase your tension data. And nowadays actually people use GAN to augment the data also. The generative adversarial network also people use to augment the data. And in case of speech, we do speech synthesis also to augment the data. Maybe in case of image, you can distort the image, scale or rotate, those kind of things you can do, or create image using graphics. And nowadays maybe using GAN also you can do those kind of things. Okay, then another thing is that early stopping. As I mentioned, this early stopping also people consider as a regularization method. Okay, and another thing you should know is that what is the parameters and what is hyperparameters. So always remember this weights and bias is a learnable parameters. You need to learn those parameters. Okay, and others like learning rate, then number of iterations, then number of epoch, then number of hidden layer, what choice of the activation function, then mini batch size. As I mentioned earlier, no, that you have 100 examples, then 10 you 10 maybe your mini batch size. So those are the hyperparameters. So you need to actually choose depending on your results. So another some kind of techniques are there where you can do the normalization of the activations, this is called the batch normalization. This is like you're normalizing of the input, but you will have some kind of learnable parameters. What we'll do generally, like this is a simple network, maybe two hidden layer is there, and each layer has two neurons. Okay, so this is input, and for this particular activation here, for particular each you can normalize your input, normalize your this activation. Okay, for each node you can do some kind of normalization. Okay, and while testing also you can just keep those normalization parameters from the 10Z, and you can do those normalization. So this is called a batch normalization. And as I mentioned, like this if you do batch normalization, your training will be more stable. Actually, generally whatever people have found, that you can see here also, like if you use batch normalization, your actually validation accuracy actually increase. So those kind of things you can do. In Keras actually you can do very simply, like if you can add those this dense layer, then you can use this batch norm, and after generally we use the batch norm before the activation function. So this way you can do the batch normalization. So there are very simple matches there. You can if you read some article and then if you watch some video, it will be very clear for you. Okay. So Subrat, can I take maybe 15 minutes? Okay. So there are some kind of other ML techniques where you can use, and you can improve your model performance. So these are different, lots of things are there, but I'm telling about the basic one. So what you can do some kind of error analysis. Okay, using that kind of error analysis, you can get some kind of insight. Okay, so what you can do, like for example, you have one trained model, you can test that model. Using that model, you just test on your test set. Okay, and check and you randomly collect some of the files. For example, you have 10,000 testing files, and you take 500 testing files from that particular test set. Okay, and you check for that particular 500 files what is the result and what is your ground truth. Okay, now you check why actually your model is not doing well. If some of the particular examples your model is not doing well, why actually that model is not doing well. So in that way, what you can do is that sometimes you may found is that when you check those test files, you may get is that your labels are not proper. That means whatever the labels you have assigned, these are not proper. Okay, so maybe you can correct those level. One thing is that. And sometimes what you may get is that, for example, when you test your model on those test set, you found that your model is doing pretty well. In case of, for example, it is a image classification for object detection. For example, you got that your model is doing pretty well in case of very clean data, like very high quality images. Your model is doing very well. Okay, but if you have some kind of blurry image or maybe poor quality image which is captured by very poor quality mobile camera, your model is not doing well. Okay, so in those kind of error analysis, what you can do is that you can pump some kind of very poor quality or maybe some blurry image or some this kind of things. You can do data augmentation to train your model. Okay, so those kind of insight you will get actually if you do do the error analysis on your test set or maybe in your test set also. Another thing is that transfer learning. This transfer learning nowadays very popular actually. If you are doing some kind of very less resource task. Okay, if you have very less amount of data, for example, you want to do some kind of speech recognition, for example, or speaker maybe speech recognition in Assamese maybe, or maybe any other language in your northeastern language. We will not get very large amount of data because we don't have that amount of data whatever we have for Hindi or maybe English. So in that scenario, we can consider those as a very less resource or zero resource language. So what we can do is that we can take some model and we can do some kind of transfer learning. Maybe we have a very good amount of very good model for Bengali, and Bengali is Assamese and relatable. So you can use those model and maybe you can do some kind of transfer learning to train your Assamese language speech recognition. Or this will be there for other tasks also. For example, you want to build a disease classification using the plant leaf. Okay, but you don't have large amount of data to do that. Okay, to train your CNN network. Okay, so what you can do is that you can take a very well trained net, maybe from ImageNet. Somebody has trained some neural network CNN architecture and ImageNet or any other kind of very large amount of data. So you can take that model and you can do tuning of that model using your small set of data for the disease classification. So this is called the transfer learning. Then multitask learning is also there. I'll just talk about. And another thing maybe I'll just talk about later, maybe that one, if time permits. Okay. So this is actually transfer learning. If you have one model A which is well trained in very large amount of data, so what you can do is that you can freeze some of the layer. For example, you have ImageNet data, and maybe ImageNet data, maybe we just consider 10,000 classes are there. Just consider, I forgot actually how many classes are there in that data. So just consider you have 10,000 examples, and your model is well trained in the ImageNet data, and you download the model from somewhere else, okay, internet, and your task is to classify the disease now, and you have very less amount of data, maybe for maybe 1,000 example for disease exists or not. That means for both the classes you have only 1,000 examples. So what you can do, you can only train the last layer, or maybe last layer maybe. So last layer, earlier you have or 10,000 examples in your pre-trained model, whatever you have downloaded, you can replace that output layer, the softmax output layer, by your model, where you have only two output. This is yes or no. Okay, so that way you can just retrain your model using your that 1000 example. So this is called the transfer learning. So people found that this is very much effective actually while doing that. And why actually transfer learning is very effective, this is a very interesting note actually, because what people found is that whatever the lower layers are there, whatever this maybe conv 1 on conv 2, they learn very low level features actually, which are not relevant, which are not directly relevant to that particular task actually. This is the general feature they will learn, that CNN will learn the general feature, maybe first one layer or second layer. Okay, once you will go to this last layer, the task dependent things will learn by the model. So in that way actually you can freeze those last layer and you can train your model. So this is called the transfer learning. Then some kind of things are there like multitask learning. If you have some kind of relatable task are there, for example, you want to classify emotion, okay, and you have gender level also. What you can do, you can just feed this network, and you can learn both this emotion also and gender. So in that way, actually, that model will learn very robust way actually. So this is called a multitask. So maybe you can learn other task also. So in that simultaneously. So this is called a multitask learning. So those things you can actually try for different tasks. So another thing is that what are the evaluation metric you should consider. Okay, so generally you have accuracy, then precision recall, F score, then word error rate for this is general one, but for specific tasks like for speech to text conversion, we have word error rate for one particular sentence, how many words are not detected properly, or how many insertions are there. Those kind of things are there for word error rate calculation. And then if you do some kind of machine translation, you'll have blue score. Then equal error rate if you do some kind of speaker verification problem. So these are different kind of evaluation metrics are there, and you need to define that before doing that particular task. Okay. Now, when what metrics will be there? Like what metrics will be useful when we do some kind of training or some kind of model evaluation? Okay. So first thing is that there are different kind of things are there. First thing is that this false positive, false negative. This matrix is called the confusion matrix. Okay, if this side is hypothesis means ground truth, this side is prediction. Okay, if your class prediction is plus that means positive, and it is detected as positive, it is called true positive. Okay, if it is the hypothesis, that means ground truth is positive but detected as negative, it is called false negative. That way actually, if it is negative, then it will be a true negative. Okay, or if it is a that negative hypothesis is negative but it is detected as positive, it is called true positive, false positive. Okay, now when we should consider the false positive or false negative as your evaluation marking, evaluation parameter. Just I'll give one example. For example, just take the false positive. Okay, now while doing the speaker verification, what is desirable is that your false positive, that means some person, if some person want to mimic your voice, or some person want to give the imposter, at that time that your system should not detect it as positive. Okay, so but it may have this false negative, like for example, I am the original person, I am speaking, but it is detected as negative, so this is fine actually. But your false positive, that means that class is negative, that person is not that person which should be, but it is detected as positive, that is not desirable. That's why your false positive should be 0. Okay, your false negative may be okay, like maybe some kind of small negative is there, this false negative is there, it is okay, but your false positive should be 0. Okay, so this is the desirable for speaker verification. Now for cancer diagnosis, what you can check is that if one person, for example, one person do not have the disease, okay, but it is detected as the but that algorithm detects as the positive, so that is not desirable, okay. So that is false negative is not desirable in case of cancer diagnosis, okay. So that two kinds of things are there. Maybe you can just check what different articles are there. You can just read what parameters we should consider while doing the project, and these are different kind of evaluation metrics are there. Okay, so actually I completed my talk. Maybe if you have some question, I can consider actually. This one case study is there. Maybe I can just share with you. You can learn that maybe. Hello, Subrat.
Yes, sir, you can go with another case study initially.
I can go.
Yes,
Okay,
sir, sure.
fine. Maybe you can just quickly. I'll just I'll just finish. Huh? Okay.
Sure.
Okay. This is a case study, like how we should do the problem formulation for a data science problem, or maybe you can say machine learning problem. Uh, Now, just consider that you are a research scientist in one of the AI labs in Assam. Okay, that's a case study. Okay, then forest department found that in several parts of Assam there are increasing number of elephant-man conflict. Okay, and they want to deploy a smart camera in the some places so that the camera send a warning signal to the nearby villagers. Okay, whenever it detects elephant presence near to it. Okay, now forest department wants you to execute this project. Okay, so this is a hypothetical actually case study. Okay, I just motivated from some of the case study whatever I found in internet. So I just make it this way. Okay, so at that point, the forest department gives you a database of 1 lakh images, which is captured from different parts of Assam using their security cameras. Just remember that thing. They captured using the security cameras, and they gave to you. Now those images are labeled as like this. If y equal to 0, there is no elephant in the image. Y equal to 1, there is an elephant in that image. And your task is to build an ML model that should be able to classify new images taken by security cameras after deployment. Okay. Now, the requirement from the forest department, because they want to deploy that model in their security cameras, okay, so your model should be very, size also very less actually, and your latency also very high in that sense, very less actually. So, the accuracy should be very low as possible, okay, and latency should be 10 milliseconds. Just hypothetically actually, 10 milliseconds is also not good, but just for example 10 milliseconds, that means within 10 milliseconds the camera should classify the images, okay. Then memory requirement of the model should be very low, maybe their requirement is 10 MB, okay. Then how you will choose the evaluation metric, how you will split your train depth and test set. Okay, so what you can do, you can just take 90,000 as a training, 5,000 as a test set. Maybe initially you can do that. Okay, then now if I ask you this, if you develop, like for example you develop some model A, model B, and model C. Okay, now which model you have to deliver to the forest department? First model, latency is 30, size is 4, and accuracy is 98. See, your first model accuracy is very high, okay, but whatever the requirement they have, this 30 millisecond latency is not according to their requirement, okay, so you can't give this model now, okay. Now this model, this one, model C, it fulfills all the requirement actually, though the accuracy is very less in this model C, but other requirement like this latency and size is very actually less compared to whatever that they have their requirement. according to their requirement. So you can give this model to them. Okay, so now here this accuracy is an optimization metric. Okay, and this latency and memory size is the satisfying metric. Okay, so you have to satisfy this latency and memory size unless and until and your accuracy is the optimization, and you are going to optimize your model in terms of accuracy, not latency and size. But in simultaneously your model and model size and latency should be less than whatever the requirement. Now uh, for example, another example, accuracy on dev set and test set is 90, 94 and 96, but the deployed scenario, you got better result using model A. Okay, so now your accuracy, whatever the accuracy you got on the dev set and test set using model A is a different example. You just consider using model A, it is a 94%, and using model B, it is a 96%. Okay. Now, when you gave that particular model, both the model actually to forest department, then they found that your model A is doing very well. Okay. This may be due to the dev set and test set is very good quality image picture, but in the deployed case, when you got very low quality images, your model is not performing well in the B. So in that scenario, what you can do is that you can do some kind of error analysis. Whatever the recent images that security cameras has taken, you can just take, and using both the models, you can do some kind of error analysis to get why actually your model is doing that way. Okay, and you can upgrade your model. Okay, now what happened? That people of Assam showed much interest in this project and to help reducing the man-elephant conflict in the Assam. Okay, therefore they voluntarily captured the elements photos using their mobile phones and DSLR cameras. Okay, and gave to the forest department. Very happy actually, like it is giving very good accuracy, for example, and people of Assam, they try to help the forest department in that scenario. Okay, so in this way forest department collected additional 1 lakh images from the people of Assam. Okay, where elephant and non-elephant into their database. Okay, now what you will do using those data? Where should we include this data? Dev set, test set, or train set? Where you will include? That is the question. Now just remember here, whatever the photos people of Assam have given, all are taken by mobile phones and DSLR. Okay, but your deployed scenario is not mobile phone and DSLR. All your deployed scenario is your security cameras. So their images are different than the mobile phone and DSLR. So what you can do, you can include these 1 lakh images into train set, but you can't include those 1 lakh images into dev set and test set because your testing scenario is not that, whatever they have given. Okay, so you can just include those images in the train set. That way your model will be robust, but you can't include those images in the test set. That you should, because that the dev set distribution will be different, whatever the deployed scenario you have. Okay, so this is true actually if you develop any kind of model which will go to the production level. Okay, now you have one problem. For example, your human level performance is 99.5%. So what is human level performance here? While if you give some images to some human, then whether this image has elephant or not, human can detect 99.5% in 99.5% accuracy. Just example. Okay, now you have train set accuracy is 94 and your dev set accuracy is 94. Okay, so what you can do, you can try some what you need to do actually now, whether you need to do some kind of regularization method or you need to train a bigger model to better for training the model. Okay, so in that scenario, what you can do, you can just train a bigger model because your train set accuracy is actually less compared to this human level performance. So what you can do, you can just train a bigger network in that case. Okay. In this scenario also, maybe you can okay, this here actually what happened, train set accuracy is 99, depth set 99, but test set accuracy is very less, like maybe 96%. So you can just this is overfit on the depth set. So maybe you can increase the depth set data, or that way you can just tune your model. Okay. Now what happened? Though your algorithm is giving very good overall accuracy, but that means overall accuracy means while classifying the human or non-human, okay, elephant or non-elephant, okay, but it possesses low false negative values. What you should do? A poor false negative will be dangerous to the people. Most of the time, camera is not detecting a true elephant image, hence not sending the warning algorithm. Okay, that means you got that. Okay, it possesses false negative. Okay, low false negative. So in that scenario, what you can do is that since your camera is not sending, if some elephant is present in that nearby, so in that scenario what you can do, you can redefine your metric. Okay, earlier your optimization metric was accuracy. Now you can change your optimization metric into false negative. So you can try to improve the false negative. So that way you can just check. So depending on the task, actually your optimization metric will be changed. So that's why actually I have given different scenarios to just to give a clear thing. Okay, now what happened? What you found is that when you did the error analysis on the images from the security cameras, that means in the deployed scenario, you have found that your algorithm is poor for the images when elephant covered by the tree. Okay, some occlusion is there. Okay, and maybe in the foggy weather. So these two scenarios, when you do some kind of error analysis on the test set, you found that for these two kind of things, you have very less accuracy. Actually, your algorithm is doing some bad result. Okay. So what you can do is that you can do some kind of data augmentation. So you can just ask the forest department to take that kind of images of elephant and give to you. Okay. In that way, actually, you can improve your model performance. Okay, so now, for example, now that forest department is very happy with your work, okay, and then they are thinking to giving another project for estimating the density of Assam pride one-horn rhino in Kaziranga National Park. Just this is a hypothetical also, okay. So in that case, what you will do now? Now that, for example, if this forest department don't have very large amount of data initially, maybe, and they gave only 10,000 good quality images of rhino. Okay. Now what will do in your first model? How you will proceed, because you can't wait to get large amount of data maybe initially. So in that scenario, what you can do, maybe you can do some kind of transfer learning kind of thing. If you get some kind of pre-trained model, which is earlier some person train that model on some kind of different object detection algorithm, and you can take those model, you can do the fine tuning using these 10,000 images. Okay. So this is the and maybe your forest department wants you to see the first model within 1 month. So at that time you can't wait like to get the maybe 1 lakh or 10 lakh images, okay, of rhino. So at that time you can do the transfer learning maybe, or maybe you can do some kind of data augmentation also. Okay. So this is a hypothetical actually case study. So that way actually it should learn, okay, because if you give some kind of interview also, actually those kind of problem formulation they will ask, and you need to define your problem formulation and how to solve that. So different kind of task you may get, and how to solve those tasks while building the model. So those kind of things are there. So in that way, I just complete my talk.
Sure, sir. So there
Now,
is
yeah,
one question from
yeah.
the audience. There is a
Okay.
lot of buzz regarding AI taking over humans in future. What is your take on that?
Okay.
Yeah,
1 second.
sure.
Okay. So in that scenario, like maybe first thing is that now anyway, like maybe after some time, what people are expecting, like after reaching the singularity, people maybe will give human will take over, like machine will take over some of the points. But before going that, actually, what we should check actually, like uh, why this whatever this buzz is there, like AI will take over, okay? Or sometimes people will say is that they develop some of the algorithm, okay, and they say that this that algorithm beats the human level performance, for example, okay. So now I'm telling about the present scenario, for example, that you develop some algorithm which can diagnose the medical, some kind of maybe some COVID or something, okay, and you say that your algorithm beats the human level performance, okay. So now in that scenario, actually, what Andrew Ng, actually, one of the known scientists of AI, what he suggests is that why we are bothering actually to beat the human level performance. So what we can do is that we can just upgrade the human level performance. So this is a very new kind of thinking people are doing actually nowadays. So what in that scenario, what you can do, for example, you have very less amount of data for a diagnosis purpose, okay, and you did some kind of, you change some model, okay, and when you train the model, you'll get the result, okay, and you just let human to upgrade his performance to level the level the some of the maybe images, because what happened in some of the tasks human level performance is very less, maybe 90% maybe, okay. So using AI, maybe some kind of explainable or AI or some kind of intuitive way, if you can improve those kind of human level performance, what you will get is that human will give you the good level data. So those data you take and again you rebuild the model. Again you upgrade the human level performance. Again you get the more amount of good level data. Again you rebuild the model. So that way it will be a iterative process. So now this kind of thinking process is there. People are thinking. So in that way, I have here I have give you a link. Okay. Yeah, this link I'll share this notebook to you. Maybe
Sure,
you
sir.
can just read this one. Yeah. So this is how to actually why we should improve the human level performance. And you can get some comments here. This is very interesting actually. You can just read that.
Sure, sir.
Now coming to this take on actually. Now see whatever the model you will build or whatever the AI system you will build. So there should be actually some social responsibility, and maybe it should not bias to some kind of category, because nowadays those kind of things are also coming.
Yeah.
So those kind of things are there. Actually, we should do a very good way to do the to build the AI model. So this is the take on actually.
Okay, sure. Sure. So one question from my side actually, sir. So what is the
Ah,
difference like in specifically in terms of research and in terms of actually deployment, like in commercial level? What is the difference in like specifically in machine learning or the artificial intelligence, specifically in these two totally different realms? Suppose that the research part and also the commercial part. What are the
okay.
differences that goes into that development part?
Okay, so first thing is that if we consider the commercial task, so whatever I currently am doing, because I also don't have much experience, because only 1 year I spent in industry.
Yes, sir.
So thing is that in industry, what is the relevant is that what is the business problem? Okay,
Yeah,
so that is more important, okay. So and that business problem you need to solve by some kind of machine learning algorithm, okay.
yeah,
So in that scenario, what will happen, if you get very good result with a very old model also, and you need to do some kind of pre-processing and post-processing on that results, okay, and you will get the result to the user, okay. This is the most important thing, okay, in that case. solving the business problem. Okay, but in research actually what we do, we just need to focus on the how to improve the performance. For example, like generally I'm speaking actually, but nowadays people are doing some tie-up for industry and academia, where
Yeah,
academia will doing some kind of problem, maybe business problem solving by the academia, also industry problem. So those kind of things are there, but that is maybe the basic difference, because we are focusing more on the research, what are the recent things are there. But nowadays anyway, if you want to do some kind of doing, especially for data science and machine learning, you need to be updated actually, you need to do some kind of, like always you need to do research on that thing also. Okay,
yeah, sure.
is
Uh,
it fine?
yes, I totally fine, sir. Sure. I'd like to ask, like from the audience, if they have any doubt, they can post on the comment section, or we can
Yeah, okay,
actually, yeah,
okay, fine, yeah.
yeah.
Before that, maybe I'll just show you one thing,
Yes, sir,
that
sure.
everybody should read this book. This is a very practical book actually. You can see now, I think.
Yes, sir, sure.
Okay, yeah, okay. So this is a book from Andrew Ng. Okay, actually I follow him very much actually.
Yeah,
So this is a very good book actually, machine learning hearing. Okay, so this is actually this is a practical strategy how we should build a model and what we should do. So that's why they have written the tactical strategy for AI engineer in the area of deep learning. Okay, so
yes,
this book actually everybody should read this book. So here you will not get very like mathematical explanation everything. Here I can see just like these are the things you will get. Okay, so this is from the point of view of practical
yeah,
scenario. Okay, he explained whatever the experience he gained over the last few so many years. So
yeah,
those experience he has written in this book, and you should read this book. And very actually not only 118 pages are there, so you should read this book. Okay,
sure, sir.
so Subrat, you can just share if somebody
Yes,
asks
sir,
this
sure,
book.
sir. I'll
Okay.
just share the
Uh,
link of your
yes,
yeah,
yes.
sure.
So this
And
is a very
yeah,
good book actually from the practical machine learning point of view,
yeah,
I can say.
yeah. And Andrew Ng obviously is one of the top researcher in as far
Yeah,
as
yeah,
the
one of the
ML
top
community is
researchers.
concerned.
Yeah,
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 yeah.
sure. Yes, sir. So I think, sir, there are no questions, so I think we'll just
Okay.
end the session.
Yes.
Thank you so much for joining in this session. And yeah, yes, and it was a beautiful session for sure. Like it was a lot of information going in. So yeah, I really
Okay.
appreciate it. Thank you so much for joining.
Thank you, Subrat. Thank you,
Yeah,
Subrat, Sasank,
yeah,
and developers, student
yeah,
club, and their team.
yeah.
Okay.
Thank you so much. Yeah.
Yeah. Thank you so much.